Hello, this is John from caveofprogramming.com. In this tutorial, this is another video from C++ for complete beginners, and we're going to start looking at variables in this video. So variables are one of the fundamental building blocks of programming languages, and we're going to just start looking at them here. So I'm going to create a new project, and hopefully you typed in this for yourself and you tried outputting different bits of text in the ways that I showed you in the last video, because that will be great preparation if you've done that. So let's go to let's go to File, New C++ Project, and let's give this a name of variables and click Finish. So we've got a new project here, and actually what I meant to do was, let's delete that. So I'll delete it and I'll say I want to delete the project contents on disk as well, because what I really wanted to do was use the basic project template. So new C++ project, hello world C++ project, variables, click Finish, and there we go. I used to re-record videos if I made a mistake, but I realized that everyone's making the same mistakes. So if I make a mistake sometimes, people are sometimes happy because they make the same mistake. Okay, so anyway, so we've got this main program. I'm going to delete this C outline here and just hit return a few times, so we've got some blank lines, we've got some space to work in here. And so we've seen that you can type stuff like cout, chevron, and in quotes, hello, and then after the closing quote, chevron, endler. That's basically what we just had a minute ago. And if I select the project, go to project, build project, and click run, and yes, I want to save it, and it says hello. Now this is a bit of text, and in the programming lingo we call bits of text strings. So this is a string, and we say this is a string literal, meaning it's the actual value of a string. It's not something that can change. It's an actual string, literally a string literal. But often in programming we want values that can change, that can be added together, that can be used later in the program, and so on. And for this we need variables. So I'm going to type something here, and it's going to look, if you've never seen it before, a bit mystifying, but I'm going to explain it. So I'm going to type int number cats equals 5 semicolon. And what this is doing is it's actually allocating a bit of the computer's memory. It's setting aside a bit of the computer's memory to store a value in, to store actually an integer value. An integer is a number that doesn't have a decimal point in it, basically like 5 or 369 or whatever. So I've written the keyword. This is a keyword, int, and you know it's a keyword because your IDE will highlight it in a particular color. So here in Eclipse it's sort of, I don't know, what is it, mauve or dark pink, I'm not sure, but it's highlighted in this brownish pinkish color along with things like this. So these are all keywords in the C++ language. C++ doesn't actually have all that many keywords, you'll be pleased to know. Whoops, Control Z, yeah. Okay, so so int means allocate me some memory for storing an integer. And then we've got a space, and then we've got the variable name. Now this is something that I've made up, as you might guess, number cats. And notice the way I've written it. So there are two words in this variable, and it's important to give variables descriptive names. They won't always have multiple words in them. But if they do, you need to differentiate the words from each other somehow. So one way that people often do this is they use underscores. So I could have typed int number underscore cats equals 5. That's the same thing. But what I've done instead is called camel casing for some reason, where we make the first letter of each subsequent word after the first one uppercase. And you have to choose one of these styles, and it doesn't matter which one you choose for your variable names, but stick to it consistently in your program. Whatever you do, don't mix this kind of thing with this kind of thing, because it looks really ugly. So your variables, if they have names of more than one word, either uppercase, subsequent words, or separated different words with underscores. So I've just made this up. It's just made up of normal letters. And you can also use numbers in variable names. You can't start them with a number. So I can't put 6 there. That's an error. You see the warning thing here. But I can put 6 at the end. So you can use numbers in variables, just not at the beginning. So they should be made up of basically normal letters, underscores, and numbers where necessary. So I've set aside a bit of memory suitable for holding an integer. I've labelled that bit of memory with the label number cats. So it's just like going up to a bit of your computer's memory and sticking a physical bit of paper on it and writing number cats on that bit of paper. You've labelled that bit of memory. And the equals 5 here says, and now put the value 5 into that memory. So that's what I'm doing there, allocating a bit of memory, giving it a label which I've made up, and sticking the value 5 in it. And this is called a variable because it can actually change. So let's see what we can do with this. Between double quotes here, with my cout, I'm going to type number of cats, semicolon, space. So this is all including the space, it's just some text. There's nothing special about that. I could type anything I wanted in there. And then after that, I'm going to put another chevron, and I'm going to put number cats in there. And now, so what we've got here, if we break it down, first we're outputting this text, number of cats, colon, space. Then we're outputting the value contained in this variable, this bit of memory, which is 5. And then we're outputting a new line character to like make any subsequent stuff that we output appear on a new line after this. And we're also flushing the buffer. So we're telling our operating system, output this text now, don't save it up and do it later. And notice I've got the tab here as well. I've indented all these statements, one tab, which is really important. So let's select the project here. Let's just run it and see what happens. And it says number of cats, 5. And we can have multiple variables in the program. So on the next line here, we could say int number dogs. And there's nothing special about this text except that it followed the conventions that I explained earlier with regard to naming. But we could call it anything. I could, call it that if I wanted. But you've got to give your variables descriptive names so that you know what they are. So I'm going to call this number dogs. This is the number of dogs that I own. I don't actually own any dogs, but just imagine. I'm going to say equals 7. So I've got 5 cats and 7 dogs. Now let's put underneath here, cout, number of dogs, colon, and then a chevron, and number dogs, and a chevron, and endler. And we should see exactly what you expect. So let's run the program, yes. And here we are, number of dogs, 7. Now we can also do stuff like adding these together. So I could say here cout, we need a kind of chevron that points towards the cout, if you like. And let's say here, between double quotes, total number of animals, colon, and then after the closing quote, chevron. And let's say number cats plus number dogs. And then let's put a chevron in and endler, like that. And let's run that. So it's going to tell us, it's going to, as you can guess, it's going to add the number of cats to the number of dogs. And then we've got total number of animals, 12. So pretty simple. But another thing that we can do with variables is we can reassign the value that they hold. That's why we call them variables, because they change, they vary. So let's output some text here. Cout new dog acquired. Acquired. How do you spell acquired? Yeah, it's like that. New dog acquired, and chevron Endler. And let's say here number dogs equals number dogs plus 1. I'm going to explain that in just a second, and then let's output cout new number of dogs, chevron, and number dogs chevron. If you feel like you're losing the plot a bit here, it'll become a lot clearer when you type it out yourself, believe me, but you do need to practice this. Let's run this, just see what happens firstly. So it says now new number of dogs is 8, so before it was 7 and now it's 8. So what happened here? What happened was this expression is read from left to right. No, from right to left, I suppose. So what we do, what we're doing is we take the existing number of dogs and we add 1 to it, and then we take that value, so reading from right to left, we take that value and we store it back in number of dogs. So the equals sign here is kind of like an instruction that says store. So from right to left, we take number of dogs, we add 1 to it, and we store it back in the original bit of memory that we've labelled number dogs. Remember, it's just a labelled bit of memory that can contain a value. And we then output that value down here. You can add variables together too. So like I could have added, I could create one called number of animals, int number animals, let's say animals equals number cats plus number dogs. And let's just change that, number animals, and I could output that. I could say, instead of putting the plus here directly in the cout statement, I could say here number animals, and that would also work. Let's run this. So it says number of animals 12. So here I've added 2 variables together. I've added the value stored in the variables together. So reading from right to left, I've got the number of dogs. So this is the memory labeled number dogs, and it's got the value 7 in it. And I've added it to the value in the memory location that I've labeled number cats. And then I've stored that value, the combined value here, I've stored it in a bit of memory which I've allocated here, suitable for storing an integer. I've stored that combined value in a bit of memory which I've labelled number animals, and here I'm outputting that value that's stored at that memory location. So if this is the first time you've seen this, and it's the first time you've thought about this, it's going to seem pretty complicated, all this talk of memory and adding values stored in memory locations and variables and stuff. But programming, it's like learning a language. Like what a lot of people do when they start learning is they try to analyze everything in minute detail. They write loads of notes, they agonize over the precise meaning of everything. But what you really need to do, what's really more important, is just to practice it, practice typing it. Because when you type it out, somehow it's like learning a human language, like learning Italian if you're not Italian or something. As you practice speaking it and using it, you get to the point where when you need a particular bit of language, it just comes out of your mouth. You just know automatically what to use. And like if you're Italian and you speak Italian, you don't spend your time agonizing about Italian grammar. You don't know the rules of Italian grammar even necessarily. You just speak it automatically. And it's similar with programming. It's really important now to go away and practice this. Type out a program like this one, If you want, start by typing this exact program, but type it all out yourself and then try changing it. Create variables that you've named yourself, put different values in them, try adding them together, try outputting them with cout, see what happens. So make up your own little program where you've got some variables and you've got variables that you're adding together and you're outputting them with cout. It's really, really important that you do that, because just watching the video, you won't learn C++. It's all about practicing it. But I hope you've basically understood roughly what's happening. And when you type this out a few times, type it out at least once and play around with it a little bit. And when you keep doing it, slowly this will start to seem intuitive and obvious, even if it seems impenetrable now. But it's vital that you do type it for yourself and get it working. Okay, so that's it for this tutorial, and until next time, happy coding.